Hey kiddos, we're going to talk today about alkene and alkyne nomenclature. Now, remember as we go through this that all the rules that we talked about for alkane nomenclature, those things are going to carry over, and that's why we spent so much time practicing those, is to make sure that we're well aware of what's going on for everything else. And so this is sort of our first functional group that we're adding in. Every functional group that we add in all year long is going to add in sort of a different little thing to what we're doing. So definition-wise, alkenes are things that have double bonds. Alkynes are things that have triple bonds between the carbons. And of course, we can arrange these in a variety of different ways. They can be in all kinds of different places, but just as a general rule, ENE means that it has a double bond. YNE means that it has a triple bond somewhere in it. Okay, and so we're going to walk sort of through the IUPAC naming conventions that are sort of the things that make it a little different than alkane. We'll talk about a couple of common names, and then of course in class we'll do a whole lot of practice with these just to make sure that we've got it. So we also have, we can have what are called dienes. We can also have trienes, tetraenes, polyenes, and that just means that there's more than one double bond somewhere in that molecule. And so if something's a diene, it's got two double bonds in it, and that's a pretty common sort of setup. Polyenes a little bit less so. But there are certainly those. If we think about some of our unsaturated fatty acids, those are going to oftentimes be things that are polyenes. And then, of course, triene would mean that we've got three double bonds. Tetraene would mean that we have four. Poly would indicate that we've got three or more, but generally speaking, more than four. Okay? What is really important for us here is to note that alkenes and alkynes are both unsaturated. And what that means, of course, is that they do not have as many hydrogens as they possibly could. If we go up and look at this molecule, if there were no double bonds here, then we would have more hydrogens. We'd have another hydrogen here and one here. We'd have one up there, and then there'd be another one on this end carbon here as well. And so we've got two double bonds in this diene, and so that means we essentially lost four hydrogens. So every time you add in a double bond, you're pulling out you're pulling out two hydrogens out of whatever the normal alkane formula would be. So if you think about an alkane formula like propane, that would be C3H8. If we then put a double bond in there and made it propene, then it's going to be C3H6 because we lost those two hydrogens. All right. So another couple of ways that we can arrange these double bonds, they're just a couple of sort of, again, definitional type things, because you'll see this somewhat. If you have multiple double bonds in a row, which is relatively rare, we would call it accumulated structure. What is much more common for you to see is what we call a conjugated structure, where you have the double bonds alternating. So you get a double bond, a single bond, and then a double bond. That is a whole lot more common than accumulated. And of course, we can certainly have non-conjugated bonds as well, which means that there's really no discernible structure. It doesn't really mean that there's like two single bonds between them. It just means that they're sort of randomly placed, that there's not like a pattern as there is in conjugated or accumulated. All right, so let's get down to brass tacks and let's talk about what the actual rules are. So here's the big one. Instead of ending in ane, as all of our alkanes did, so instead of having ethane, if we have a double bond, it's going to end in ene. And if we had a triple bond, it would end in yne. And those are pronounced ene and ine. And so in this case, that means that this particular molecule then, if we were going to give it the IUPAC designation, that this molecule is going to be ethene. Now, we'll see here in a minute that, as with a lot of things we talked about in the last unit, it never really gets called ethene, or not very often. It has a common name, and we'll talk about what that is in a little bit. Okay, so change the ending to ene from what it originally was. That's the first thing that you do when you have a double bond. Okay, so what else changes about the rules? Well, according to the rules that we had last time, we would find the longest chain and we would name it according to that. So we would say, like, okay, that's pentane because that's a 5-carbon chain. But in reality, if we have a double bond here, we have to pick the longest chain that has the double bond in it. So in this particular case, our longest chain is not a 5-carbon pentane. This is a not a 6-carbon hexane. This is a 5-carbon pentene, because we have to take the longest chain that includes the double bond. Okay, and so I can't just take this 6 straight across here. I've got to take the 5 there because that's what's going to include that double bond. Okay, so now numbering. Numbering becomes really important. We go by the same general rule as we did when we talked about branching and all that in alkanes. But now what overrides the numbering is that we have to number it so that the double bond gets the lowest possible number. And that makes sense because when we talked about the branches, we worried about getting the lowest possible numbers. And so that's going to be the same thing here. So again, I'm going to say, okay, well, this is my 5-carbon chain that contains the double bond. And so then when I go through a number, that's going to be 1, and carbon 2, 3, 4, and 5. Okay, so I couldn't number from this end. I wouldn't number it 1, 2, 3, 4, 5. I would number it from the end closest to where the double bond is. Okay, so that's relatively straightforward. I don't think that's going to be too much of a problem. That's the same general thing that we did last time, except that now it's the multiple bond that matters. Okay, so next thing. If there is a multi-bond and we've done our numbering, so going back to what we had last time, and let me just throw the numbers up here again. 1, 2, 3, 4. Sorry, you have no idea how hard it is to write with this tablet. And 5. So if we number those according to the scheme that we just gave, then we're going to number the bond when we give its location. We're going to number the bond according to the lowest number because technically this double bond touches both the 1 and the 2 carbon, okay? But you always number it or name it according to the lowest carbon that it's attached to, okay? Again, pretty straightforward. We're trying to keep the numbers as low as possible. That's a general IUPAC rule for when we're naming things. And so that allows us to come almost all the way to be able to name this guy. Essentially, if we're going to name this now, we would say, okay, longest carbon chain is 5. It's going to end in ENE, so I know that it's going to be pentene. Okay. I also know that the double bond is at 1. Okay. So that's a 1 pentene, and then I know that there is a 2-carbon chain or an ethyl group attached at the 2nd carbon. Okay, and so that then makes that 2-ethyl 1-pentene. Okay, not terribly complicated. One of the things that you'll see that here that's a little bit different is that when we had the numbers last time, that number would have been attached to a branch, but this one here is indicating that that is where the double bond there is in the ene. Now, sometimes we have to plug that in over here, depending on the particular formula. And we'll work on some of those in class so that you'll understand why that would go in that particular place. All right, one last rule, and then we'll talk about some common names. So if there's more than one multiple bond, okay, as there is in this case, so if we, again, longest chain, this chain contains both of my bonds. And in that case, so I've got a 5-carbon chain, so I know it's a pentadiene, right, because I've got 2 double bonds, so that's diene. And then how do I number it in that case? Can I number from this side again? And again, the rule still applies that you number it according to what's going to get you the lowest possible number. So the same thing is going to be true here. 1, 2, 3, 4, and 5. And so what changes this time about what this molecule is named according to what we had before? Well, I've still got the same ethyl group at the 2nd carbon, so I can start there. So I've got 2-ethyl. And now I have 2 places with a double bond. So I've got a double bond starting at the 1st carbon and a double bond starting at the 3rd carbon. So now that becomes 1, 3. Remember, separate the numbers with a comma just like you did when you were doing a dimethyl or something like that. And so that then is a pentadiene. And you're like, would I put a tri in there? You absolutely would if you were doing that same thing. Okay, so 2-ethyl 1,3-pentadiene would be our correct IUPAC name for this particular molecule. All right, so real quick, let's talk about some common names, and then, of course, we'll work a bunch of these in class to get some practice on them. So these 5 things, the bad news with common names, just as we talked about when we talked about isopropyl and all that stuff in the alkanes, is that you just have to know them. And this is, again, one of those things that makes organic chem a little bit more complicated, is because there is a correct way to name them, IUPAC, but then there's names that have just been around for a long time. So these 5 names, you'll just have to make sure that you know. Ethylene is the correct name, or the IUPAC name would be ethene. Ethine, and I don't believe, honestly, that I've ever really heard this called ethine outside of discussing it as IUPAC. That's always called acetylene, okay, the stuff that's in welders' torches. Propylene and vinyl, you've probably heard those before because you've heard of them in the context of polymers, plastics. So you've heard polypropylene, where there's a bunch of these linked together, or polyvinyl chloride, which would be PVC pipes, that's this vinyl group here. And what you'll notice here with the vinyl and the allo is that these are substituent groups, right? So instead of calling this an ethanyl group hanging off of this, we would call it a vinyl group or an allo group that's hanging off in these particular cases. So a vinyl group would essentially be an ethylene, but with a hydrogen hanging off, and so it's a branch now. And an allo group would be a propylene, but again with one of the hydrogens off of it, and it's attached to a longer chain. All right. Hope that gave you what you needed to know there, guys, and I appreciate you listening.